Welcome back, everyone. We're starting chapter 2. Chapter 1 was all about reviewing things that you need for calculus that you've already learned. Chapter 2 is all about giving you the tools that you need so that we can actually do calculus, but it's all new stuff, very possibly things that you've never seen before. And then chapter 3, we actually start doing some of the more intense calculus stuff. All right, let's get started. We're going to talk about the tangent and velocity problem. This was something that Sir Isaac Newton was pondering when he accidentally discovered or created calculus. He's one of two people that created calculus. And this is a famous equation. It may not look like it, but this is a rock is launched vertically upward from the ground. And we're using this equation that ends a typo there. That shouldn't be there. S of t is equal to negative 16t squared plus 96t. And the negative 16 is because gravity is downward. That's why it's negative. And the 96 is the initial speed that the rock is launched. And we're going to talk about average velocity. And ideally, we eventually want to come to instantaneous velocity. So we're going to find the average velocity and between 1 second and 3 seconds. And the formula that we'll need for that is here. And you can see it's the slope formula, right? Y sub 2 minus y sub 1, x sub 2 minus x sub 1, and so on. And so what we're going to do is, in this case, this is my t sub 1 and my t sub 2. And we're going to go ahead and do this. So let's find the average velocity. We need s of 3. And when we plug 3 into here and here, we get that s of 3 is 144. And when I plug in a 1 here and here, we get 80 over 3 minus 1. And so again, here's our t sub 2 and t sub 1. And when we throw that into a calculator, we get that the average velocity from 1 second to 3 seconds is about 32. This is in feet per second. And to be clear, this is this line. From here's 1 second to 3 seconds. We'll get to what that line is called here in just a moment. We're going to do the same formula again, except this time we're going to do from 1 to 2 seconds. So the average velocity is going to be s of 2, which we calculated out to be 128 when I plug in a 2 into here and here, minus s sub 1. And s sub 1 we already know is 80 over 2 minus 1. And that, when we crunch all that together, ends up being 48 feet per second. And that is going to be this line here. And I want to point out, you can see that the slope of this line is changing, right? It started here and now it's a little bit steeper. Now, ideally, what we want to have is we want to have exactly 1 second. What is the instantaneous velocity? And you can see as we started with time 3, we went down to 2, and if we went to 1.5, and then 1.25, and then 1.1, and so on, that we're going to get a smaller denominator, which in some cases could be a problem, but we're going to have a fancy way out of that. Now, these lines that I just drew here, these are called secant lines. Is a line joining 2 points on a curve, which is exactly what we did here. And once again, the slope of the secant line is here. And Once again, you can see that is just the slope function there. That's nothing too new. And so what we're doing, so this is the same curve that we had a moment ago. And I'm going to draw on the secant lines again. So our first secant line started here, went through here like this. And our second secant line went through here and here. And once again, you can see that slope is changing. And our goal is to end up with what's called a tangent line, meaning it's a line that goes through and just touches the graph at one point. This is the tangent line. And so to sum up, this lesson's particularly short. If we take the limit as t approaches 1 of the average velocity, we get the limit as t approaches 1 of s sub t minus s sub 1 over t minus 1. Now, that might look a little weird to us because we have still t's in there and things like that. But you can see as t is approaching 1, that's approaching 0 in the denominator. So we're going to have a way to combat that. Now, we've already calculated that as we go from 1 to 3, our average velocity, we calculated above is 32 feet per second. And we also did 1 to 2. And we got 48 feet per second. And if we keep going, meaning I take 1.5 and I plug it into there and there, and then the one we already have, if we were to calculate that out, we would end up with 56 feet per second. You can verify all of this with your calculator. And if we go from 1 to 1.01, we're going to get 63.84 feet per second. And if we go from 1 to 1.001, we are approaching 63.984 feet per second. And can you see that we are definitely approaching, as we get closer and closer and closer, that's getting closer and closer to 64 feet per second. So in this case, our limit is going to be 64 feet per second. And this is what's referred to as instantaneous velocity. That's it. And that's going to be a major goal of a lot of what we're doing in Calculus 1 at the beginning. Hope that helped.